Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amirul Bishafiri. My student ID number is 2019243822. I am from class J4EM 11040G. As for today, I'm going to do an explanation about experiment for lab 4, which is advanced lab. Okay, now we'll go through to the product that we want to produce at the end of this process. So as you can see here, at the left side we got part 1, which is the process that will be used to produce this part is milling. And then at the right side, part 2, the process that will be used is turning. So as you can see right here, I already numbered the step, which is the first one is the face, and then the second one is here, which is the center drill, and then third is the drill. Fourth, we have tapping, which is over here, and then number 5 is rough for this part, and lastly number 6 is for finish. Okay, and then moving on to the process for the part 2, which is process turning. For the first one here is the rough, and then number 2 is finish, number 3 is rough, and then number 4 is face finish, sorry, and then number 5 is over here, which is center drill. Then number 6 is drill. Number 7 is tapping. Number 8 is rough. Then number 9 finish. Then lastly number 10 is pad off. So for the metal joining process used is hall tap bolt, which is M20 times 2.5. So we also have to notice that the stock material for part 1 and 2 is still low carbon. Okay, now I will do one explanation about one of the process of milling, which is process number 2. So for the part A is center drill. Then for part B, which is item number 1, is cutting tool that will be used during this process is center bit drill, which is countersunk HSS. So next to the item number 3, which is number of inserts or flutes is 2. Now move on to the part C. So the cutter material that will be used is HSS, as we learned before. For drilling and tapping will be used, the cutter material is HSS. Okay, so and then to get all of this value, we can open to a little machine shop. Okay, so the first thing is we have to change the unit of measure to the millimeter. Then for this, which is for this process, which is center drill, we have to use the operation drilling here. And then for the material, as I mentioned before, it's use steel low carbon. Okay, and then we go to the end mill diameter, which is end mill diameter will be 20, and then end mill here is 20. Okay, then we the machine max is 6,000. It is 5,000 to 5,000 or to 6,000. So I'll choose 6,000 and the cutter edge is 2. And then just press the calculate. Okay, then we will get for the cutting speed, which is 29, and then for the spindle speed, which is 460 rpm, and then chip load is 0.36 0.396 mm and ref, and then for the feed rate is 183 mm per minute. Okay, so it's all same as here. I will zoom it a little bit. Okay, now we'll move on to the estimated time in minute, which is um, the formula is length of cut over feet. So the length of cut for this part is length of cut is 5 mm. Then for the feet, we can take it from here, feed rate, which is 183, and then when we divide it, we will get 0.027 minute. And this is the graphic illustration, which is for part D. And then so that's for part 1, which is process milling. And then this is for process turning. Let me see. Okay, turning also. I will explain one process, one of the process for turning. Okay, so the machining process is rough contour, and then the holder that will be used is tools indexable holder, right side with offset. And then for the cutting tool is turning insert carbide, and the cutting tool is trapezium. Okay, and then for the application is dynamic bar, which is copying, and the boring type is ESDVC-A, and the size is 32 mm. So for the cutting material is carbide, and the cutting speed is 244. The workpiece diameter is 60 mm. The machine max is 6,000. Cutting edges or flutes 1. Spindle speed is 1,290 rpm. Chip load 0.521 mm over mm per ref, and then the feed rate is 674 mm per minute. So it's also use the same method as I explained for the milling process. Just insert the cutting material, the workpiece. I'm sorry, the cutting material, workpiece diameter, machine max, and cutting edge. Yeah, same. And then for the estimated time, also the formula is same, which is length of cut divide by feet. So it is 50 divided by 674. Then we will get 0.12 minute. And this is the graphic illustration. Now I will show you the time lapse of me doing the drawing of one of the process of milling. Okay, so that's all for me. Yep, that's all for me. Thank you, and Assalamualaikum warahmatullahi wabarakatuh.